Hey everyone, it's Mr. Prevet back here to do the 2022 FRQ number 1. Excited to dive into this with you guys today. I really appreciate all of you watching this video. I hope it really helps you, prepares you for the AP exam, and just improves your knowledge of calculus. But today we're going to be looking at this question that, from my looking at it, it seems like it's going to be talking about an accumulation function and some of its properties, which I find really interesting. So this should be a fantastic FRQ. So let's read it together. It says from 5 a.m. to 10 a.m., the rate at which vehicles arrive at a certain toll plaza is given by the function a of t equals 450 root sine of 0.6t, where t is the number of hours after 5 a.m. and a of t is measured in vehicles per hour. It says traffic is flowing smoothly at 5 a.m. with no vehicles waiting in line. Okay. So we have this rate function, a of t, right? This is not the amount of vehicles that are in line or the amount of vehicles that arrive. It's the rate at which they arrive. So part A says write but do not evaluate an integral expression that gives the total number of vehicles that arrive at the toll plaza from 6 a.m. t equals 1 to 10 a.m. t equals 5. So let's think about this. We have a rate function. When I integrate a rate function over a certain time interval, in this case, it is from 1 to 5, our a of t, this will give us the accumulation of change of this function over the time interval. So this would give us the number of vehicles that arrive at the toll plaza. Whenever I take a definite integral of a rate of change, that is just the accumulation. Now, if they didn't ask us to do it, but if I wanted to solve this integral, I could go to math, go all the way down to fn, int, and I can solve a definite integral. Could go from 1 to 5, and I could plug in the function like 450. I won't type it all out. We plug it in, say dx, and solve, and that would give us the value of this integral. I might also rewrite it just with the actual function in there. So 450 root sine 0.62t, just to ensure that we earn all the points. That will be the total number of vehicles that arrive. So the big thing for you is remember that when we integrate a rate function over a time interval, that gives us the accumulation of, in this case, number of vehicles arriving at the plaza. So that is the answer to part A. Pretty simple, pretty easy to start out. Let's move on to part B. So part B, if we were to read it, it says find the average value of the rate in vehicles per hour at which vehicles arrive at the toll plaza from t equals 1 to t equals 5. Okay. Now, the average value of any function is equal to the integral from a to b of f of x dx. Imagine that our function is in terms of x, divided by b minus a. That is the average value of any function, right? Now, if I wanted to find the average value of the rate function, well, the rate function is a of t, and they want the average value from 1 to 5. So it would be the integral from 1 to 5, which we actually just talked about solving, divided by 5 minus 1. And this would give you my accumulation of change divided by the amount of time that has passed. So I can, I can plug this in just like I was saying, go down to function int. I'll go from 1 to 5 of, now I'll type in my function, 450 times the square root of sine 0.62 I'll use x instead of t. It's fine as long as we use the same variable, dx. I'll click enter to evaluate this. And I get 1502.14. And then I will divide it by the length of the interval, which is equal to 4. So the average rate is equal to 375.5. And if we were to think about like our units, it is vehicles per hour. And that would be our final answer to this question. So really not too bad. I think the great thing is this integral, it's really easily solvable with a calculator. Sometimes these types of integrals are definitely more difficult if we have to like actually solve it. But because we have the calculator, super straightforward. Just got to remember to divide by the length of the interval too to get the average rate instead of the whole rate. But that's the answer to part B. So far, honestly, A and B, relatively simple if we know what's going on with average values and accumulation functions. But let's move on to part C. Maybe this one will be difficult. It always feels like whenever A and B are like super doable, C is like impossible, D is impossible, but we'll see what happens. So part C says, is the rate at which vehicles arrive at the toll plaza at 6 a.m. increasing or decreasing? Okay. And it says, give a reason for your answer. So we want to justify this. Now it asks if the rate at which vehicles arrive at the toll plaza, well, the rate at which they arrive is just A of t, right? That's our rate function. And they're asking if at 6 a.m., so when t equals 1, is this function A of t increasing or decreasing? Now we know if a function is increasing, its derivative is greater than 0. So that would mean a prime of t is greater than 0. And if it were decreasing, it would mean a prime of t was less than 0. Now the great thing is, we have our a of t. We know that the rate is equal to 450 root sine of 0.62t. So all I need to do is take the derivative of this function and then evaluate it at t is equal to 1. And basically just solve for a prime of 1. And if that's greater than 0, then our function is increasing. If it's less than 0, then our function is decreasing. Now, similarly to how we took the definite integral in part B, another really awesome tool that your calculator has is if you click math and you go all the way down to number 8, it is in deriv, right? And what that allows us to do is find the derivative of a function at a point. So I'll do the derivative of my function, which is 450 times the square root of sine of 0.62x. Perfect. And I will do it at x is equal to 1. And that is just evaluating this right there. I click enter, I evaluate it, and I get 148.9. And this is very clearly a positive value, right? So because this is positive, our rate of cars entering the plaza is increasing because the derivative of our function is positive at the point. So not too bad. But yeah. So that is our answer to part C. Once again, honestly, I don't think it's too bad. That one was worth 2 points. B was worth 2 points. A was just worth 1 point. So, whenever we've got these easier parts earlier on, we can always feel part D is probably going to be a real pain. So this will be the final part, and we can expect it will probably be the most difficult as well. But let's look at it together. So part D says a line forms whenever A of t is greater than or equal to 400. And it says the number of vehicles in line time t for t is between A and 4 is given by n of t is equal to the integral from a to t of a of x minus 400 dx, where a is the time when a line first begins to form. To the nearest whole number, find the greatest number of vehicles in line at the toll plaza in the time interval where t is between a and 4. Okay. So this is an interesting question, right? We're saying at some point where A of t probably starts to equal 400, a line begins to form, right? And that is at time A. And then from time A to time t, we are integrating the rate of change of, this function minus 400, which is going to give us the number of vehicles in there at a certain time, right? So let's think about it. We are trying to find the greatest number of vehicles. So we are trying to maximize n of t. Now, when we try and find an absolute maximum over an interval, there are a few places that we need to check, right? I need to check endpoints, and I need to check relative extrema, or in this case, relative maximums. Now, we know that our endpoints are, here, I'll write those down. We'll put them right here. So our endpoints are t is equal to a, and t equals 4, right? That's our endpoints just based on the interval that they give us. Now, the relative maximum is where our derivative goes from positive to negative. So let's think about it. If I were to take the derivative of this function, I would get n prime of t equals the derivative, if you know this integral from a to t, a of x minus 400 dx. Really messy, right? But the second fundamental theorem of calculus makes this really simple. A lot of times we see this as a function of t, and then we're going from a to x. This time it's reversed. But n prime of t, using the second fundamental theorem of calculus, will be a of t minus 400. Okay? So we're trying to figure out when a of t equals 400, right? And that will be our starting point. So let's try and figure this out, right? So let's see, because we need this to go from positive to negative in order for there to be a relative maximum. I don't really have a great way of solving this algebraically. So what I'm going to do instead to find this point is graph it. If I go to my graph and I type in my function, 450 root sine of 0.62 x, right? Make sure you got the right number of parentheses. And then I'm going to subtract 400, okay? I'll graph this. Now, my window is all sorts of messed up. So I'm going to fix it. I'm going to make my minimum x value 0. That's reasonable. I'll make my x maximum value 4, right? Because this integral only goes from a to 4, okay? And then my y minimum we'll figure out later. But if I graph it, I get these values. In order to kind of fix that, I'll go to zoom. And if I go to zoom fit, click enter, it kind of gives me the perfect fit of this graph. So based on this, we can tell a couple of things, right? A of t is greater than 400 when this is positive, right? Because that would have to be greater than 400. And that's when our line starts, right at the very beginning. So, let's see, I'll trace it. Oh. But if I find this point where I cross the x-axis for the first time, that is going to be my point A. And then my relative maximum is where this also equals 0 out here at this other intersection point. That will be our relative maximum. So we can solve for, these points A, and I don't know what we could call that point, maybe T1. Let's do it. If I go to calc and I try and find my 0, I'll get a left bound and a right bound. Click enter, and I get that my T value is equal to 3.598. And this is my relative maximum, right? So that's my relative maximum. I could go and find my relative minimum if I really wanted to. Why not? Let's do it. I'll go to 0. My relative minimum happens when this function goes from negative to positive. Right? Click enter. So A is equal to 1.469, right? So now we have our endpoints, and this is our relative maximum. So now to find the absolute maximum, right? We just want the greatest number on this interval. I need to find the values at each of these points. So this will be, n of A, n of 3.598, and n of 4. And we already said A. I'll fill it in. It's 1.469, right? And I need to calculate each of these three integrals and see which one is the greatest, right? So, based on this, let's go ahead and solve it. Now, this first one, based on our initial function n, this is going to be from A, which is, or it's just going from A to A of this function, A of x minus 400 dx. And we know whenever a function goes from A to A, this function will actually just equal 0, right? So my function n of 1.469, that's just equal to 0. Now n of 3.598, that would be represented by an integral. So I'll go down to my definite integral calculator and go from 1.469 to 3.598. I'm going from A to T, right? Of my function minus 400. My function is 450 times the square root of sine 0.62x minus 400. So perfect. And I'm going to do that dx. I click enter, and this gives me 71.25. So that is the number of vehicles in the lot at this point, right? And it's to the nearest whole number. So if this is correct, it would be 71 total vehicles, right? Now, n of 4, I just do the same calculator. Go down to function derivative, 1.469 to 4 of, once again, got to type it out, 450 root sine of 0.62x, parentheses, minus 400 dx. Click enter, and I get that's equal to 62.5 0.34. So I'm just looking to compare these values. This one is 0. Those two of them, the greatest is 71.25. Now the question asks us to round to the nearest whole number. So our answer would be 71 vehicles. So this is a really challenging part. This probably took like half of the time that we've spent together. This was really challenging. Solving for points A and B gave us half of the questions. Also, if we consider where this is 0, right, by showing a graph. So half of the points are really easy. Just, taking the derivative, solving for the minimum and maximum. But solving for these points and plugging it in, doing the definite integrals can take a lot of time. There's a lot of concepts that are gone through in this question. I think as a whole, absolute minimums and maximums are one of the hardest topics for people to comprehend in AP Calc AB, just because of how time consuming they are. Even if the steps aren't complicated, you can spend like, I don't know, maybe half of your time on an entire question just doing this part, which is really challenging, right? So it's a tough question. So if you followed along, you are doing absolutely fantastic. You're killing it. But that's all we got for question number 1. I hope that you guys were able to gain something, just increase your knowledge base. And yeah, I really hope to see you guys in the next video. See y'all.